There's a timestamp in the description where I speedrun the entire thing on hyperlapse, but if you want to see me explain each and every step, continue watching. Alright, y'all, this is the little petite problem we're going to solve today. This problem is full of a bunch of tricks. If you don't know how to do those tricks, the problem seems really impossible. If you know how to do the tricks, the problem is pretty easy. I'm not going to really go that much into how these tricks work now. You can do your own research on that because I just want to get to the point. You know, we're just going to do it the problem the way it goes. But I will explain a bit, but I won't explain in depth how the tricks work. First things first, what we're going to do is we're going to make our limit, our whole entire big behind problem, our whole entire pretty problem. We're going to make this equal to L. Matter of fact, let me put L in red because that's important because L is what we want to find. We want to find L. All right? Now, why do we make it into an equation? Why is that important? We just made the problem into an equation. Just because with equations, you can manipulate them. You can natural log both sides, and that's what we're going to do next. You can natural log both sides to any equation because the natural log function is a one-to-one function. Just there's one little thing, they both need to be positive, so it works out in this problem. However, other problems it may not work out. That's why I don't like getting into the nitty-gritty of why this stuff works. Let's just go through the problem. This is what our equation looks like now. Now what we're going to do is this side of the equation, that's kind of good. We're not going to mess with that till the end. So we're just going to try to modify this little expression. And we're going to call it expression 1. So let's work with this expression. Natural log of whatever this serves as a function of x. We can switch the limit and the function. Get into that a little bit later, but yeah, that's how it works. You can just pull a little switcheroo. And that is equal to
limit first of x approaches infinity, natural log of all that crap. Okay?
Whenever I have natural log of x to the 5th, that's equal to 5 natural log of x. Alright, I bet y'all get the next trick. This is basically pash p, a log property where you can place the exponent of one log into the front to make it a coefficient, and bada bing bada boom, you're done. This little joint down. So then we have
limit
Alright, the next part of this problem requires some visionary thinking, some critical thinking, and I'm going to get into the nitty-gritty of that. If you just want to know how to do this problem step by step, then you can skip the pink highlighted part of this video. But if you really want to know how you think about it, then you can watch. So when x approaches that infinity, this is obviously going to approach infinity. This part of the problem, only this is obviously going to approach infinity, right? And you should also have the natural log graph in mind. The natural log graph,
if you don't know, you should have this cement in your brain, by the way. Like, you should
when someone says natural log graph, you should pull out this. And you know that when x equals 1, natural log of 1 equals 0. Right? And in your brain, in that brain of yours, you should be thinking that this, when x approaches infinity, it's going to get smaller and smaller. It's going to approach 0. That means this entire thing, you're going to get 1 plus 0, which means that you're going to get natural log of 1, which equals 0, or approaches 0. So then, basically, all in all, what this means, what all that yellow means, is that you're probably going to get something like infinity times 0. Which is an indeterminate, right? How do we stop indeterminates? We get El Hospital. But we can't, or L'Hopital, the more accurate way to say it. I'm sorry, I just say El Hospital a lot. I can't use El Hospital right now. So what we do is we're going to have to do which is the same thing as this because it's the reciprocal And then, right now, you can use L'Hopital, or I call it El Hospital, and then solve the problem. I'm not going to try to get into the logic and reasoning behind this, so you understand that or you cannot understand that. But anyways, that means that our next step, we need to make x the reciprocal. That's the little trick right there. We need to say that multiplying by x, multiplying something by x, that's a multiplication by x, is the same thing as dividing something by 1 over x. That's facts right there. Okay? So, that's equal to natural log of 1 plus 1 over x. Then you just do the reciprocal. Because that's their equal statements, alright? Now, knowing that, then we can now plug in infinity. If x is approaching infinity, this approaches 0. That's obvious. A 1 over a really, really big number approaches 0. So you're going to have natural log of 1 plus 0. What you're also going to have, you can also do the same thing, this approaches 0 too. So 0, right? That's equal to natural log of 1 plus 0 is equal to natural log of 1. Know the natural log function graph. Natural log of 1 is also 0. So you get 0 over 0. This right there, it is an indeterminate. And then we use L'Hopital, also known as El Hospital. It's probably spelled wrong. Let's use L'Hopital. So we need to refer back to this part to use L'Hopital. L'Hopital means you need to derive the numerator and the denominator with respect to x. So d over, this is involving some calculus, so I guess if you don't know calculus, I'm sorry. Alright, a couple of things here. First of all, make sure you're deriving both sides with respect to x. Secondly, when you have that natural log, make sure you keep on deriving. So not only do you do the reciprocal rule with the natural log, you need to keep on deriving that 1 over x. And then you do the same thing at the bottom. Pretty simple derivation. Let's do a bit of canceling. Boop, boop. That's the logic. That's the problem. If x approaches infinity, this approaches 0. Yay! We definitely solved it. Wow. It equals 1. Well, remember that E1 thing? I'm just going to try to modify this little expression. And we're going to call it expression 1. So that's
little expression. And we're going to call it expression 1. Expression 1. Expression 1.
E1 equals 1. We need to plug it back into this equation.
E1 this is our problem. Equals.
This is just you raise everything to the e power, because if you were to raise this to the e power, then a log and its base cancel out, because natural log is the same thing as log base e, and like e to log base e is just 1. Just saying. They basically cancel out. And what you basically get is, we're going to switch up the equation. E. Beautiful, pretty E. It's equal to E. And yeah, I'm honestly kind of dead. It's early in the morning. I'm tired. I want to go back to sleep. So I'm signing off right now. That's my signature. Before I start this hyperlapse, I want to say if you don't make your limits in cursive, it's just weird. If you don't make your x's in cursive, that's also weird. Just like a lot of things are pretty weird. But anyways, let's get into this hyperlapse.